In the previous video, we've covered the basics of working with structs in Go programming language. Today, we're going to learn about the combination of structs and JSON. JSON stands for JavaScript Object Notation. It is a lightweight data interchange format. Even though it's derived from JavaScript, it is a common data format and nowadays used quite often in many programming languages. Here is a small example of how a JSON looks. It consists of an object or a list of objects. The object is enclosed in curly braces and contains key value pairs separated by a colon, where a key is a string and a value can be also a string, a number, another object, an array, or a boolean. As you can see, it looks quite close to Go structs. We can say it has fields with some values. When we pass a JSON around, we pass it as a string. Most modern programming languages provide the functionality to encode and decode a JSON. And Go is not an exception here. To work with a JSON in Go, we are going to use encoding JSON package from a standard library. Now let me grab a restaurant structure from a previous video so we can experiment with it. The JSON package provides two ways of encoding and decoding a JSON. Those are marshal, unmarshal, and encode, decode. Let's start from marshal. The JSON marshal accepts an argument of any type and returns two values, a slice of bytes and an error. If we receive an error, we stop the program execution. Otherwise, we print the result as a string. As you can see, that's a JSON representation of our restaurant structure. Now, if we need to parse some JSON into a structure, we can use JSON unmarshal method. In this example, we call the unmarshal method and pass a slice of bytes as a first argument and the pointer to a new variable r2. The first argument is the result of a previous example, and it is a string representation of our JSON. The method returns an error. If there is no error, the variable r2 will populate it with the data from a JSON, and it does. Now let's look at the encode and decode methods, which have slightly different behavior. Let's jump straight to example. First, we call new encoder, which accepts any writer. A writer is any type that implements a write method. We're going to talk about that in one of our future videos. For now, think of it as some sort of destination where we can write. In this case, a standard output, which is our screen. It can also be a web page, a network call, and so on. New encoder returns an encoder and we chain it with the encode method, which accepts any type. In our case, it's our restaurant structure. And of course, it returns an error which we need to handle. You can see that we didn't call the print function and yet it prints the result on the screen. Again, that's because we set a writer to be a screen and the encoder writes into it. The opposite approach is to use a combination of decoder and decode method. Let's see it in action. In this case, new decoder accepts a reader, which is a source we can read from. Again, that can be terminal, a network request, and so on. For the sake of example, we create a reader from a slice of bytes, which contains the JSON from the previous steps. Then we call a decode method and pass an address of our new variable R3. After the successful call, we'll get the variable populated with the data from a JSON string, and you can see it on the screen. Now let's make a small step backward and check the another method. As you can see, when we print a result of a marshal method, that prints the JSON as a single line. The JSON package provides a marshal indent method to apply some indentation rules. Let's try to apply the indentation of 4 spaces before each key. Now every JSON key indented with 4 spaces, and it makes it much more easier to read. Let's quickly review the difference between marshal, unmarshal, and encode decode. As we learned here, the marshal method returns a result which we can store into a variable and then use it any way we want. We can print it, pass it to a function, and so on. Unmarshal is similar. It accepts a JSON as a slice of byte, which is a string. On the other hand, encode does not return a result and print it straight to a writer. And the decode method receives a raw JSON from some readers. So which one of these methods to use? As always, it depends. In different situations, one approach can be more suitable than the other. Alright, let's move on. There is another thing we need to mention when encoding or decoding a JSON. The fields in the structure have to be exported field, started with a capital case letter, if we want to use them in the JSON. The lowercase fields will be ignored. To demonstrate that, let's unexport the address field. Now we can see what the resulting JSON does not contain the address. So the fields we want to get into final JSON have to be exported. That brings us to another topic. Until now, all the fields of our restaurant structure was converted to JSON keys as we defined in the struct. As a result, they are capitalized. Sometimes, when we send or receive a JSON, we need to have a lowercase keys or snake case keys or keys with different names. As we just saw, we cannot just convert field names to lowercase letter. So how do we solve that issue? That's where the field tags come in handy. A field tag is a string of metadata associated with a field of a struct. Let me quickly define them so we can see it in action. Let's see what we have here. Tags can be any string, which usually contains a key value pair separated with spaces. Tags are defined using a string literal because they contain double quotes most of the time. JSON-specific tags has the following format. The lowercase JSON word as a key, followed by a colon and then a value enclosed in double quotes. For the ID, name, address, and rating, our tags specify new names for the resulting JSON. It defines what we want to use lowercase names and address word for address. We can also ignore some fields by using a dash as a value. We do that for website field. The delivery value has two values. First, we rename it to be hasDeliveryKey, and we also want to skip a field if that's not populated. Now let's run the program again to see the result. The JSON now has key specified by tags. You can also see it doesn't contain delivery because the restaurant struct doesn't set it. Let's add it quickly and run the program again. And now we have it. Besides the JSON package, there are a bunch of other packages for different formats, such as XML, YAML, and so on. These packages usually have a similar API, so we can use the unmarshal method to convert the struct to the YAML format. For example, and we can do the same with the XML. As you can see, our JSON uses the address as a key, but the YAML and XML still uses ADDR. That's because we defined field tags only for a JSON. We can define them for YAML and XML as well. More than that, we can combine several formats. All we need is to separate them with a space. Now we have the address fields for every format. Let's review what we have covered in this video. We have seen how we can use a JSON package to encode a struct into a JSON and decode it back using two different ways. We've learned about field tags that help us customize the resulting JSON. And we also saw quick examples of encoding and decoding YAML and XML formats. Now it is your turn to try it out. See you next time.